Hello, and welcome to my advanced button tutorial with wiringPi and Raspberry Pi. I labeled this tutorial as advanced since I will be using the C programming language, and I hope that you know C well enough to be at least familiar with pointers. You can still benefit if you are a beginner, but I hope that you will not hold it against me if I don't explain everything to an absolute detail. If you just want to learn how to use buttons with Raspberry Pi and don't need to do it in C, I recommend Python, and I have another tutorial just for that. If you are a beginner C programmer, I recommend that you watch my introductory C tutorial first before proceeding with this one. This tutorial is split into two parts. Part 1, which you are currently watching, covers current wiringPi situation and the circuit needed for this project. If you have used wiringPi already, know how to connect buttons and LEDs to the Raspberry Pi, and know all about pull-up and pull-down resistors, you could go straight to part 2, which is just the coding. This tutorial is applicable to Raspberry Pi 3 and earlier, as of recording date, which is late February 2021. Unfortunately, the wiringPi library is broken on Raspberry Pi 4 right now. Gordon Henderson, the creator of wiringPi library, has deprecated the project and has not open sourced the code yet. This is too bad, as there are cases when Python is just not good enough, and wiringPi fills that need nicely. Perhaps by the time you are watching this video, wiringPi has been made open source and someone else picked it up and fixed it. There are a couple of unofficial wiringPi forks available, but I haven't tried them. You can test whether wiringPi works on your system using a few shell commands. Let me demonstrate it on my Pi 4 system. If this was a new Raspberry Pi OS install, using wiringPi produces an error on Raspberry Pi 4. The stock wiringPi version 2.5 does not recognize the new hardware. You can manually download and install a newer version, which happens to be 2.52 today. This is the last official release. This version will allow you to use the GPIO command to view the port status and even activate the ports for input. You can blink LEDs, etc. I demonstrate the basics in my wiringPi introductory tutorial video. Unfortunately, the wiringPi library cannot be used beyond basics on Raspberry Pi 4 today. For example, if I try to use pull-up resistor with an input, the command silently fails and has no effect. In contrast, the stock wiringPi version 2.5 works just fine on my Raspberry Pi 3. I will be using the Pi 3 system for the rest of this tutorial, but I would welcome your comment if you adopted my code to a later version of the Pi. I have mentioned something called a pull-up resistor a few moments ago. Pull-up and pull-down resistors are used to enforce a default state for digital inputs, logical 1 or high, or logical 0 or low, respectively. This is necessary as without these resistors, digital inputs would continuously change their state in a random fashion. Button inputs without default state would continuously register with the system as button presses, which is obviously not something that you would want. Most Raspberry Pi GPIO ports have built-in pull-up and pull-down resistors, and it's just a matter of choosing which one you want. All you need to remember what the default state is when a specific resistor is used, and the fact that the input state changes to the opposite when the button is pressed. I use pull-up resistors in this tutorial, mostly because I try to keep inputs and outputs on separate sides of the GPIO headers, and as it happens, there is no 3.3 volt pin on my button side. I don't want to bring it over from the other side, as I like to keep the breadboard wires to minimum. The minimalistic goal is also why my buttons are placed in what some may see as an unusual location. Most people place their buttons in the middle of the breadboard. I choose to remove one pin from my buttons, which allows me to plug them in directly into the power rail. The incoming connection is on the diagonal from the grounded pin. That's it for part 1. We are ready to start the code.